In the heart of a modern industrial zone stands a tannery built for one purpose: turning raw animal hides into durable leather.
Right here.
This is where thousands of
bites, we
skins
need to
begin
mark
their
this section
transformation.
clearly.
A truck arrives, loaded with salted cow hides, still heavy, still carrying the smell of preservation. Workers unload the cargo quickly. Time matters, because the raw material can degrade fast. The hides are stacked in the receiving zone. Every pile contains animals from different suppliers, and every batch must be handled with precision. Each hide is weighed. The tannery pays by weight, and this step also helps calculate chemical requirements for the entire process. Skilled sorters check the hides for defects, scars, and thickness. Bigger, cleaner hides move to premium leather lines. Damaged ones go to lower grade production. Conveyor belts move the salted hides inward. Salt is still embedded, but soon it'll be washed away. The hides arrive at massive rotating drums, giant machines designed to rehydrate and clean skins that may have been stored for months. Workers load the hides into the drum. Once the door locks, the process cannot be interrupted. Inside, water floods the chamber. As the drum rotates, the hides slam against each other, loosening dirt and salt. Salt dissolves into the water and drains away. Decades ago, this was manual labor. Today, automation handles it efficiently. The drum empties, leaving swollen, rehydrated hides. They are heavier now, and ready for the next stage. The hides move toward the fleshing zone. This is where excess fat and tissue are removed. Operators guide each hide into the machines. One wrong move, and the blades can destroy the material. Rotating blades strip away fat and connective tissue. This waste is collected for industrial byproducts. The waste falls into bins, thick, pale material that once protected the animal's body. The hide emerges thinner, cleaner, and more flexible, but still far from resembling leather. Next, the hides enter the liming section. This is where hair removal and fiber opening take place. Workers mix lime and sodium sulfide, a powerful alkaline solution designed to break down hair follicles. The hides are loaded into the liming drum. Once the chemicals enter, the transformation begins immediately. Under the alkaline attack, hair starts dissolving. The follicles weaken, separating naturally from the skin. A technician checks the pH of the liming solution. The chemistry must stay highly alkaline. Even a small shift can ruin the fiber structure. Inside the rotating drum, hides tumble continuously. The motion ensures every part absorbs the lime evenly. After hours of liming, hair is loosened completely. What doesn't dissolve is mechanically removed in the depilation stage. Removed hair travels down conveyors into disposal bins. Modern tanneries recycle some of this waste into fertilizer additives.
Keep that centered, it's about to hit the side.
The hides move to the deliming area. Now the goal is to neutralize the strong alkaline content. A spray tunnel applies deliming agents that lower the pH step by step. Rapid pH swings would damage the hide. The hides are drained, leaving them softer and ready for the next biochemical treatment. Technicians prepare enzyme-based baiting solutions. These enzymes clean residual proteins and refine the grain surface. The hides enter the baiting drum, where controlled enzyme activity completes the cleaning process. At a microscopic level, the enzymes relax the collagen fibers, giving future leather its flexibility. The hides come out smoother, cleaner, and free of unwanted proteins. A conveyor wash removes any leftover enzyme solution, preventing overprocessing. Next comes pickling, the acidic stage that stabilizes the hide and prepares it for chrome tanning. Salt and acid are mixed precisely. The salt protects fibers, while the acid tightens them. Inside the drum, the solution circulates through every fold of the hide. The collagen structure tightens, giving the hide the strength it needs for the chemical reaction that follows.
All right, heave.
The
Keep it
hides
steady
emerge
now.
pale and firm,
Got it.
fully pickled and stabilized. A new drum is prepared for chrome tanning, the most common method worldwide. Trivalent chromium salts are added. This chemical bonds deeply with collagen fibers. Inside the drum, chrome penetrates the hide. The material slowly turns its signature wet blue color. A technician cuts a thin slice from a hide. The cross-section reveals whether chrome has penetrated completely. Any pale center means incomplete tanning. The drum drains out the used chrome liquor. What remains inside are fully tanned, stabilized hides. The material, now called wet blue, is stacked. It's flexible, cool to the touch, and resistant to decay. Conveyors transport the wet blue hides to the next stage. Excess water still needs to be removed. A sammying machine presses the hides between heavy rollers, squeezing out moisture without damaging the fibers. A worker checks the hides manually. The moisture must be reduced, but not completely removed, or the leather becomes too stiff for splitting. Next, the hides move to the splitting machine. This determines final thickness and separates grain from flesh layers. As the hide enters, sharp internal blades separate it into precise layers. Two sheets emerge, the top grain layer and the lower split layer. Each will be used for different leather products. To ensure uniform thickness, hides are fed into the shaving machine. Rotating blades shave microscopic layers from the flesh side. The goal is exact thickness across the entire hide. Technicians measure thickness with digital gauges. Consistency is non-negotiable for high-quality leather. The hides move into neutralization. This step balances the acidity left from chrome and prepares fibers for retanning and dye. Neutralizing agents enter the drum, carefully regulated to bring the pH to the ideal level. Inside the drum, hides tumble, while the chemicals circulate evenly. The hides emerge with a stable pH, ready for the chemical treatments that define final softness and strength. Technicians prepare retanning chemicals, syntans, resins, and natural tannins. Each formula creates different leather characteristics. The retan solution enters the drum. This stage reinforces structure, improves fullness, and enhances feel. Inside, retain agents penetrate the fibers. The hide slowly develops body and firmness. A sample is taken and stretched by hand. The technician checks fiber tightness and flexibility. If the balance isn't right, adjustments are made. The hides move to the dyeing section. Large rotating drums are prepared. Each batch requires precise temperature and timing. Technicians dissolve powdered dyes into water, creating a uniform solution. The color must be stable under heat and rotation. The dye solution enters the drum. Once sealed, the hides tumble inside to ensure full penetration. Inside, the color spreads through the fibers. True quality dyeing means the color reaches the core, not just the surface. A worker removes a sample hide, bends it, and examines the fold. Any unevenness means the batch needs more time or more dye. The drum drains out the colored water. What remains is fully dyed leather, rich and saturated. Fat liquors, specialized oils, are prepared. This step determines the final softness and flexibility of the leather. The oils are poured into the drum. As it rotates, they absorb deep into the fibers. Inside, the fat liquor spreads through the hide. Without this, the leather would be stiff and brittle. The hides come out heavier and smoother. This stage marks the end of wet processing. Each hide is stretched onto metal toggle frames. This removes wrinkles and sets the flat shape. Frames move into drying chambers, where warm air circulates steadily. Slow drying prevents cracks or surface defects. Inside the room, rows of stretched hides hang under controlled heat, slowly releasing moisture. For thicker hides, vacuum drying is used. The machine removes water under reduced pressure. Under vacuum, moisture evaporates at lower temperatures, protecting fiber structure from damage. Some hides are hung on moving rails for air drying. This method is slower, but preserves natural softness. Semi-dry hides fall from hooks, ready for mechanical softening. The staking machine is prepared. Its job is to beat and stretch the leather to soften it. The machine repeatedly strikes the hide, opening fibers and giving the leather a supple feel. A worker bends the hide, testing softness and drape. If the grain feels stiff, more staking is required. The hides enter the finishing hall. The first step, buffing. A large machine fitted with abrasive rollers prepares the flesh side. The rollers sand away tiny imperfections. This creates a smoother, more uniform surface for later coating. A powerful vacuum extracts fine leather dust. Without this, particles would contaminate the next finishing layers. Technicians examine the hides under strong light. Any uneven areas are marked and corrected. Next, the hides go into a milling drum. This mechanical tumbling gives the leather a natural grain and softer hand feel. Inside, hides tumble freely. The controlled friction relaxes fibers, creating a premium texture. When the drum opens, a soft cloud of loosened fibers escapes, evidence of proper milling. The leather now shows a fuller grain and a warm, natural feel. This stage makes a major difference in final quality. Technicians mix pigments and binders to create the base coat. This layer evens out color and hides minor defects. Nozzles are adjusted across a conveyor line. Spray finishing requires perfect calibration for consistency. As hides pass through, fine mist layers coat the surface. Too much spray causes cracking. Too little leaves imperfections visible. The coated hides move into drying tunnels. Controlled heat binds the pigments to the grain. For areas missed by machines, workers apply pigment manually with sponges. This ensures uniform tone on complex grain patterns. A roller coater is prepared to apply the top finish. This layer gives durability, gloss, and resistance. The roller spreads a thin, even coat across the leather. This determines how the final product will shine and feel. The hides move through UV light tunnels. The top coat polymerizes instantly, locking the surface finish in place. Heavy metal embossing plates are heated. These plates imprint patterns, from pebble grain to exotic textures. The hides slide in the hydraulic embossing press. Pressure and heat reshape the surface permanently. The press clamps shut with massive force. Seconds later, the leather adopts a precise, repeated pattern. The newly embossed hide emerges with crisp, defined grain. This is the texture consumers recognize in high-quality leather goods. The finishing hall prepares the ironing machine. This step smooths the grain and locks the embossed pattern. Under intense heat and pressure, the machine glides across the leather, flattening micro-wrinkles and refining the shine. Technicians scan the hide for flaws, scratches, uneven coating, grain distortions. Every defect is logged before grading. Each hide is graded. Top-grade leather moves to premium production. Lower grades go to budget goods. Nothing leaves this room unclassified. A digital system measures total usable area. Buyers pay based on square footage, so accuracy is essential. In the cutting department, freshly finished leather arrives. Here, hides are transformed into product components. Workers spread each hide on wide tables, checking tension and flatness to avoid distortion during cutting. Metal dies representing each bag component, front panels, straps, gussets, are arranged strategically to minimize waste. A hydraulic press slams down with precision, punching out shapes cleanly from the hide. Workers collect freshly cut components and sort them by type. Each piece must match exact size specifications. Panels, straps, pockets, and gussets are separated into bins. Uniformity here prevents problems during stitching. The skiving machine is prepared. This step thins the edges of leather pieces, so folded sections don't become bulky. The machine shaves a consistent taper along the edges. Clean skiving ensures tight, seamless stitching later. Fabric reinforcements or interlinings are added to areas that need strength. Handles, strap ends, and structural panels. Workers mix edge paint for final finishing. This paint seals cut edges and prevents fraying. With small brushes, workers apply paint to every exposed edge. It's slow, but essential for a professional finish. Painted pieces move along a drying line. Multiple coats may be needed depending on the design. Now the pieces enter the stitching room, the heart of assembly. Machines hum constantly as workers build the bag. Panels are sewn together with high tensile thread. Precision matters. A single crooked line can ruin the final appearance. The lining is stitched in, giving structure and a clean interior. Pockets and compartments are added here. Metal hardware, buckles, rings, zippers, studs, is laid out. Each piece is quality checked before use. Handles are stitched and reinforced. These must carry the weight of the entire bag, so durability is critical. Zippers are attached to the main opening or pockets. Alignment must be perfect to avoid future complaints. Brand logos, metal badges, and decorative buttons are fixed in place. This step defines the product's visual identity. Side gussets are attached, shaping the bag's final form. This is where flat pieces become three-dimensional. The bag is turned right side out. The structure appears clean, firm, and aligned. Workers clean off dust, polish the surface, and trim any loose threads. This finishes the product's visual appeal. Final quality checks inspect stitching strength, hardware alignment, color consistency, and structural stability. The approved bag is stuffed with paper, wrapped in protective sheets, and placed into branded packaging. The final product stands ready, crafted from raw cowhide to a finished, polished handbag. This is the complete journey from tannery to consumer.